2 plus 2t. That's an s, yeah? Right, look like an s. Next one, this is the y, isn't it? 4 plus 2t, 4 plus t. Oh no, you're right, 4 plus t. And the next one should be 14 minus s. Right, which one have you done? Did you have to multiply anything?
No.
That's what we've done.
So
Minus them.
I mean, add them.
I would have added.
Added them. I did them, so they cancelled out.
That's perfect. That's perfect. Carry on with that so you can solve that t. Fine. No, what's that? Right, you've had about 2 minutes. Can I stop everyone there? Just put your boards up for me so I can see where you've gotten to in these 2 minutes. Right, perfect. Boards down, keep going. What is that?
S.
How's an S changed to a 10? So look. What you get? S is 7, T is 3. So where have you substituted that into to find where have you took it? So from the Z's, I got minus 7 plus 60 plus 2s. Now, if they intersect, we're saying where the z coordinates are equal to each other. What do you get, t? Right, boys and girls. So we've seen a nice example, but now I'd like to try it for yourself. So on your whiteboards, can you have a go at the following question? If we're given the two vector equations of r is equal to 2i plus 4j minus 7k plus t outside of 2i plus j plus 3k, can you solve that simultaneously with the next equation that we've got down here? Right. Now once you've solved it simultaneously, I want you to first of all work out whether they intersect, and if they do, find the point of intersection. We'll give you 5 minutes to have a go at this. Time starts now, guys and girls. Yeah. Eight equals 8. Now, if you've got 8 is equal to 8,
This
what?
was plus 2. So before that one before.
Right, so you shouldn't have got 8 is equal to 8 then. 8 plus s, in the second, 4 plus 2 is equal to 14 minus s. Now what did you do there? Those two, you added them together.
Because
That's fine. This one will get you 3t is equal to 9, t is equal, that's fine. And once you've got t is equal to 3, where did you substitute that
First
into?
one.
First one. 6.
2 7 and then
Yeah, you got s is equal to positive 7. Now this shouldn't have worked then, should it? So if you
What?
put t is equal to 3 into the z coordinates, so we've got, where's your z coordinate?
no, but first don't you put them here to check?
Ah, no, you don't have to put them in there. Because we've already proven that it works for the x and y values, so you've put them back into the x coordinates here. Don't want to check it for the x coordinates. We've just shown that the x and y coordinates are going to be able to solve. It's the z coordinates that we're now checking. Okay. So you solve it for x and y, you get your values of t and s for the x and y coordinates, you check it only with the z's. Okay, so start that bit again here. I'll run through it really quickly because I want to show you that it doesn't work, so you can do this question. Z coordinate. If they're equal, you get minus 7 plus 3t is equal to what?
16 plus 2s.
Perfect. Now if you substitute in this one, t is 3. What do you get here?
9, 2, so on.
S. If S is 7, what will you get here?
14 plus 30.
Okay, so you get 16 plus 14. Does 2 equal to the number 30?
No.
So do the lines intersect with those? No. So now what we're going to do, we've just changed it, make that one a minus 2. So start those bits again. You will find a couple of things change. Start them again, I'll give you a couple of minutes. See whether or not they now intersect. Okay, keep going. Let's write them. Right, so if they intersect, sorry, can you just hold your boards up for me there? Thanks. Have you worked out the point they intersect at? Right, if you've worked out that they do or don't intersect, if they intersect, could you try and find the coordinate at which they now intersect?
The mirror face the front.
You're happy 2 does equal to 2. So that means they must intersect. Let's check that. Hold on, chill out for a second. Right. I've only got a limited amount of time with you guys and girls, so I'm going to move you on from there. Just hold your books, your boards up so you can see where you've gotten to in those couple of minutes. Right, okay. I got a different point of intersection to that. Just check that you've subbed in your S&T as the right ones. That's perfect, that's perfect. Perfect. So look to me. No, no, cool. Right, okay. Last 30 seconds, and I'm going to move everybody on to the next task. If you've finished, wipe your boards clean, pack your boards away for me, you're not going to be using them again. What do you get? Should have got, because that one's changed to a negative. Yeah, but this one has to change. So let's just check the equations. It should be the z's you change later on. Yeah. Substitute into here. 3 minus 7 plus 9 is like 8. 2. What's 16? Take away 2s. What's 2s got to be? Right, so we get 16 take away 14 because s is equal to 7. 7 times by 2 is 14. Right, so because we've got the z coordinates equal to each other, yes, they do intersect. Now all you've got to work out is the point. So what do you do to find the point?
We put the T here and that's it.
Perfect. Do that for me really quickly. I'm just going to move everyone on. Okay. I'm really happy with that. I've had a look at everybody's boards and everyone's either got the right answer or they're very close to finding the right answer. What we should have found out was that T is 3, S is minus 7, and we calculated the position vector as well. And you should have got 8, 7, and 2. And I see that most of you have got that. Right. I'm going to move you on now to a Sage Inscribe activity. You've done them before. Let's just get straight stuck into it. For those of you that can't remember what to do, Sage is the person that talks, and the scribe is the person who writes. Yeah, thank you. Okay, you get 1 between 2, 1 between 2, 1 between 2, 1 between 2, and the other, because unfortunately, now it's not in, you can do that on your own. Okay, Sage Inscribe activity has got 2 questions on there. So as we've done before, the Sage is going to be speaking, okay, explaining the solution. The scribe is going to be writing down everything that the Sage is explaining to them. If at any point the Sage and the scribe disagree, so the scribe is writing down the answer and he thinks, hold on, no, he's told me something wrong there, that's when you stop and discuss. When you get on to question 2, you're going to swap roles. Any problems? Okay, Sage, scribe. Sage, scribe. Sage, scribe. Abdullah, you're the Sage and scribe. In fact, I'll work with you. Okay? If you finish this exercise, once you've finished it, guys and girls, can you move on to page 81, finish exercise 5I, which is on solving these simultaneously. All right, any problems? All right, carry on now, please. I want to be hearing you. Come on. Right, I'm going to Yeah, do you want to be the sage or you want to be the scribe? How about you be the sage, you talk to me how you solve that. You tell me what you do. Yeah, the first one. Column vector principle, so I'm going to get 2 plus
Okay.
2.
Now for the do an arrow for the first one, right? 2 plus 90. No, wait. Yeah, yeah.
Hello, sir, can I help?
2 plus 90. And then 2 plus 2 minus 2.
Minus.
Minus
Still
minus 3 minus 2.
minus 3.
Yeah, I'll make it equal to each other. Minus
So plus 90. And we rank the second one as well.
2 plus 90 is
The two.
equal to 3 plus 2.
Okay, there's no space to write it on the negative.
No,
Okay. 2 minus 2t equal
plus 2.
minus
And next to it, 2 plus, no, minus 2 equals,
yeah, we can. Yes, yes, yes. So can you write this one as well first? So 4 minus 4t equal minus 2 minus 2s.
4 minus 2
And
equals minus 2 minus 2x. Do a rectangle on the first one. Or just the,
can I make them? Yeah, 6 minus. Okay.
Just write
You did it already.
So
3
write 2
plus minus 3 minus 2 1.
equals
That's 0. 5t equal to 6 minus 5. T equals minus 1. And which one is easier? I think. Yeah, okay. 2 plus 2 minus 9 equals 3 plus 2. No, 2 minus 9 because this one is minus 1. Oh yeah, okay.
So make it 92 minus 2s equals.
Two minus. Yeah, minus 3 plus 2. That minus t. Yeah. Mi-
7 minus 5 for
So you
s.
solve the x's and the y's.
So
It's the
Sir, we did put
2 plus 3, open brackets, minus 5, close brackets,
So far, we've only used these two. We multiplied this one by
equals
2.
minus 13.
Well, in fact, we multiplied this one by 2.
And I use the second equation for z, minus 3 minus t.
We've said, right, the x's and the y's do intersect.
Sub in the value for t, minus 1, minus 3,
Sir, we did
minus
put
minus.
this. That's how we get
So it's going to be minus 2. So they don't
Where did
intersect.
we put this one? Yeah.
We put them in
Yeah, we didn't put
there.
them in the
Should have put them in there, shouldn't we? Right,
That's what
okay.
I thought.
Let's try it again. This time
R
in the
equals?
z's. So you've got minus 3 minus t is equal to
Which
2
bracket?
plus 3s. That's your z's.
12
And we've got
minus
that
2t.
s is equal to minus 5. We've got t is equal to minus 1.
And do that.
Minus 3 plus 1 equals 2, minus 2. And then equals 2, this is plus, right?
Yeah. 2
Minus 15.
minus 15. Right. What's minus 3 plus 1?
They don't intersect.
Right, and you can see that because that one's going to get you minus 2, that one's going to get you minus 13. They do not equal each other for the z coordinates, so just write down, do not intersect. Right, and have a little wander around and do the second one. Thanks, Abdullah.
Minus 3 minus
I'll
minus
call
1.
glimpses of each of them. Great stuff.
I think that's everything. Thank you.